All right, so we're just going to talk about lessons for building on generative AI. Specifically, right, 4 keys for building on generative AI that we found while building a infrastructure-specific coding agent. We'll kind of get to some of the reasoning behind that, but I'm Adam. I'm a community engineer at Pulumi. This is Artur. He is a software engineer at Pulumi. And how many people are familiar with infrastructure as code, like, at all? Like, raise your hands. Like, lots of people. Okay, that's good. So Pulumi's flagship product is infrastructure as code, and this is just an example of some infrastructure as code, where we are setting up an S3 bucket, and then inside that S3 bucket, we put this hello MCP Academy inside the bucket. And the cool thing about it, right, is it's code. This isn't TypeScript. You can use whatever language you might desire within reason, and you can describe your code declaratively. Cool thing about that for this particular talk in this conference, right, is because it's just code, coding agents are great at writing code, right? Easy to get started with that, and you may not think that you need much more than your standard cursor, right? So I could take Windsurf, I could start writing infrastructure as code, and a lot of people, as they start using Pulumi, will do that, right? Have a project, I want to get it into AWS. I'm going to open up my editor. I'm going to say, like, write me some Pulumi code to set this up. But it can go badly occasionally. I don't want to sell out the person that the screenshots are from, except it was me. But I was working on a demo. I had to put together this example of setting up a Kubernetes cluster with some services inside of it. And so I was asking Windsurf to write the Pulumi code for that, and it did it, and it did a great job. And I was like, okay, Windsurf, go, apply that to my AWS account. And of course, although you're probably not supposed to, I was running Windsurf in like the YOLO, you can do anything mode. And I left. I was scrolling Twitter. I got a coffee. Setting up a Kubernetes cluster takes a little bit of time. And I came back, and I can scroll through all these messages. And if you look closely, you can see the problem is it stopped using Pulumi, and it started just using the AWS console to make changes to my cloud account. So I believe somewhere in the middle of this, the code, it ran into a problem with it, and it said, you know what? I'm going to give up on the Pulumi you asked me to do, and I'm just going to start figuring out how to set up things in your cloud account. So this can go really bad, right? This is just an agent running wild in the cloud. This was just a demo account, so thankfully, everything's fine. But I think it shows the value of an MCP tool. So our first lesson is that you should prefer an MCP tool over a CLI tool if possible. Because what was happening here is I wanted to get that loop where it could examine what was happening in the cloud and use that to update the code. However, I didn't actually want it to have write access. I asked it to run Pulumi up at the CLI. However, once I gave it blanket CLI access and it ran into problems, it could start using AWS and going sideways. So first lesson, be careful what you allow it to do. Prefer a tool, an MCP tool, where you can. So Pulumi then built this Pulumi MCP tool. I'll show you a little bit of that. So the Pulumi MCP tool is a server MCP tool. And so the cool thing is I could give it credentials to be able to talk to the cloud, to read in the state of things that are happening there. And that way it can write changes based on my instructions, but also be able to see the state that's happening in the cloud without being able to actually make changes, right? So this was just me recording a demo of I had this container. And I'm like, let's get this running in AWS. This is using VS Code. This is using Claude Code within VS Code. And it works pretty well. And a cool feature that this MCP server has that Artur actually built is if you think about deploying something into AWS, AWS has 1,000 different building blocks. You say, like, hey, run this in AWS. What do you want it to actually do, right? Do you want it to just pick a random service and set that up? Or do you know exactly what you want? And you want to specify that down, exactly how everything works. Well, there's a middle ground that this tool will actually take a look at your code. Here I have a container. It will then offer, based on best practices, oh, there's a couple different things you could do, right? You could do a Lambda, you could do ECS, you could do, I don't know, it offers you options, right? So here's some of the options. Here, we could do a Lambda, we could use App Runner, we could do Fargate, and I think I end up doing Fargate. But this is something cool that you can do with an MCP tool, actually kind of have a wizard and drive people through a process. Actually, I don't need to know how to use Fargate, but based on the pros and cons, I think that's the right choice. And so I rolled this out, and it's working well, and it's great. The MCP tool is making these things easier for me to do, except some more problems. So that was Claude Code. Coincidentally, Artur, when he built this, was using Claude Code. Then I started testing this tool in various other coding agents, right? So I'm back in Windsurf now. I install it, and then I ask it, let's run through this process. And it does ask me for feedback on what cloud I should use. And I say, hey, let's do Lambdas. And then it says, okay, here's some instructions for setting up the Lambda. You do that. And I said, like, no, I think you're confused about the relationship here. Like, I tell you what to do, you go do that. And I had some of these back and forths with Windsurf and couldn't get it to quite work. I provided feedback to the team. They improved it a little bit. But then I was testing in Devon being a coding agent, in the cloud with its own environment, going through the exact same scenario. And Devon sometimes would do the opposite. So it would say, like, hey, there's a bunch of different ways you could run it in the cloud. What should you choose? And if you can see here, it might be a little hard to see, but it didn't wait for me. It just said, I think what you want is Lambdas. And it just ran off with it, that is. So that's one of the challenges that we have of building MCP tools, right? You don't control actually where people run them, what other tools are installed alongside them, what those tools do if they have interfering names, or if they're just using a model that's not powerful for whatever they're doing, or if compaction happens in the middle. You actually need, if you're building a tool like this, to test it, right? You need to test it across a variety of scenarios. Maybe you can make it work better by trying some weaker models. Maybe there's models where it's just not going to work. But you need to expect that. You need to expect the unexpected. To overcome that problem, Pulumi built something called Pulumi Neo. So this is our infrastructure coding agent. And much like Devon, that I was just showing earlier, right? It runs in the cloud. It has its own, environment there. It's aware of your infrastructure. It can, you can connect it to your GitHub, connect to your cloud accounts. It can do things like, hey, I need to be SOC 2 compliant. Let's look through your cloud. Let's find problems with that. I think it's about to show a diagram, which is really cool. Let's see. Yeah, so here, I wanted to get SOC 2 compliant, and it flagged that I had this Bastion host that was open, and it made this diagram. I didn't even actually know it could do this at the time. And it's like, this is the problem right here in red, which is really cool. So this solves the problem of control, right? Now we control everything. This has its own environment it's running in. We choose the base model. We spend a lot of time making sure it has all the knowledge about your infrastructure that it needs to run, right? But there's another problem with this, right? Everybody here has their favorite coding agent, whether it's like Claude Code or whether it's Cursor or whether they're using Windsurf or Devon. And now we've built this tool that has this ability to do great infrastructure changes, but you already have a coding tool of choice, right? So how do we cross that divide, right? Which brings me to Artur's turn, which is finding ways to meet users where they are.
Thank you, Adam. So in Pulumi, we lean pretty heavily into MCP tools in all of our AI efforts. When building Neo that Adam has talked about, we defined every tool that we have as an MCP tool. Some of them we built ourselves, others we borrowed and reused. So to connect you to your Pulumi cloud, that's the tool that's the MCP tools that we built. To connect you to your source control, to your file system, we've reused other tools that are available to us. For Pulumi MCP server, we also used a subset of the same tools so we can reuse our functionality. And in addition to that, we build a tool, and I'll talk about that in a couple of minutes, specifically to connect you from your AI assistant of your choice to Neo. So yeah, MCP tools are fundamental and essential, but they're kind of very low level. I think of MCP tools as system calls. They're super important, super effective at connecting you to the outside world. But composing them together is still pretty hard. You have to rely on your MCP client to carefully orchestrate the calls between the tools. When you define the tools, you want to make sure that you are specific enough, but not overly fine-grained, because you don't want to end up with 1,000 different tools inside the MCP server. You also want to make sure that your tools are comprehensive and solve the big problem, but at the same time, you don't want to go too coarse-grained, because otherwise you would be introducing potential conflicts and ambiguities with other tools. And that's the problem with composition today. In fact, the state of AI programming kind of reminds me of the state of software development in the 70s. We still lack high-level compositional tools. We're still running around writing go-to statements and keeping our state and global variables. Imagine if your programming language like C++ or Java didn't have a concept of a class or a package or a module. That's kind of the state that we are in currently. I see some gray hairs in the audience, so hopefully my metaphor will resonate. So yeah, going back to the composition, some of the things I already mentioned. Context pollution. You've tested your application, you composed it carefully with a set of tools that are appropriate, and then you add another MCP tool, and suddenly you broke something else that's already tested. But that's a compositional problem. So context pollution is one big problem. It's also expensive, right? Every time you define an MCP tool, you contribute to your token consumption. And this is not even mentioning execution of the tool, right? Because executing MCP tools can really blow your context out of the water. The only way that we can build complex, sophisticated software is by creating layers of abstraction and composing it from composable primitives. This is true in general. This also applies to AI, building AI software. But the units of composition are going to be different. And the challenges that we are facing are also going to be somewhat different. The units of composition, those big Lego blocks that we want to use to compose our AI software, are going to be skills and agent. You really want to delegate your task to a sub-agent that is able to independently, within its own context, solve the problem, come up with a result, and give you back that result, right, without polluting your context. Potentially using its own specialized LLM if necessary, but not necessarily. Some of the unique challenges involve having human in the loop, right? In the context of Pulumi, I can give an example that is fairly typical, a situation that Project Neo was specifically designed to address. And the query could go something like this. Hey, agent, please identify all of my outdated RDS databases, upgrade them, making sure that there is no downtime and no data loss, and perform data migration if necessary. Neo handles that, right? Now, imagine if your agent receiving that query would tell you, okay, I'm on it, chugga, 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 in a couple of minutes that I'm done, right? That would be absolutely terrifying, right? We are not ready to give AI this level of autonomy. So human in the loop is absolutely essential. You want to be able, your inner agent wants to be able to communicate back to your outer agent, request additional information, request approvals. But there are challenges, of course, because your inner agent doesn't have access to the UI. It doesn't know if it's been called from the console or from UI or from the browser, right? MCP protocol supports features such as elicitation and sampling, but going back to Adam's point, meeting users where they are. We really want to make sure that the capabilities that we provide are available in the AI assistant of your choice. And nowadays, very few AI assistants actually support those advanced features. So we decided to take a stab at agent-to-agent integration, and we built this tool that we call Neo Bridge, or Bridge to Neo. And with this tool, you as a user will be able to ask questions like, ask Neo to tell me about my cloud infrastructure and tell me if I have any policy violations in my S3 buckets, like very typical cloud infrastructure related question. This query will formulate a specific query, a specific question to Neo, call into Neo, collect the results, and presents the results back to you. It's not quite that simple because, as I mentioned, human in the loop, right? This tool also will be able to kind of monitor and shepherd through the execution of that task inside your inner agent, which is Neo, and handle cases like additional information, gathering and approvals and all that. And so you get a more engaging experience, almost as if you were logged into Pulumi console and using Neo within the Pulumi console. And MCP tools, where MCP protocol in general wasn't really created and designed with those use cases in mind. And so a couple of key discoveries or insights that made this implementation possible is, number one, even though MCP tools are supposed to be one-shot operation, input goes in, output comes back, it's possible to define, to return, I have more data, call me again, flag as part of the output. And this is what allows MCP clients, and all MCP clients that we tested support that and can handle this pretty well. This is what allows them to call this tool repeatedly, in effect implementing polling. And this way, your outer agent would call the tool, get the information, call the tool again, get the other information, and so the user gets an engaging experience. The other key insight here is that even though MCP tools are stateless, again, data goes in, output or result comes back, MCP servers themselves don't have to be stateless. They can maintain state. And that state can be persistent. And so this is what allows the server to maintain where each client is in the conversation and to provide a subsequent chunk of information on each subsequent call of the Neo Bridge tool. And so we've implemented it and we've used it internally, we use it externally. It turns out this tool actually works pretty well. But of course, there are some issues, right? And this is where we see where the state of the MCP protocol in general isn't quite up where we need to be, and also maybe some lack of ingenuity on our part. The first thing is, which is both a feature and a bug, is I call this a split brains situation, where your inner agent and your outer agent have slightly or potentially significantly different views of the world. And it is a feature because when you delegate a task, you really want that task to be executed within the context of the inner agent without polluting the scope of the caller agent. So that's a good thing, right? What is less good is that sometimes the inner agent would not have enough context to answer your question, really truly understanding your situation. So an example of that would be you're having a conversation within your outer agent, Cloud Code or Windsurf, and you say, my preferred cloud is Azure, okay? And then several turns later in the conversation, you would say, hey, ask Neo if it supports if it has a secret management solution that could be relevant for me, right? Now, the fact that you are Azure user may or may not be visible to the inner agent, right? That really depends on how that tool formulates the question and how it packages up that information. And so, it requires some care. Sometimes it works and sometimes it does not. The other issue is that when the data comes back, your inner agent has already summarized the information, and it gives you that information that's ready to be presented to the user. However, from the outer agent point of view, it's just a tool call, right? And it sees the information coming from the tool. It needs to summarize it again. So we have this double summarization situation where some information is removed from the summary, and then we summarize it again, and then again there is a chance for us to lose even more information. But overall, if you understand those issues, then the tool is still usable. So how do we bring AI development into the modern world? I would say again that MCP is foundational. Start with MCP. With a little bit of ingenuity, you can build a fairly complex system, and you can go from an agent with a myriad of functions to a more capable, scalable, and sophisticated AI software. It is possible today. We're hoping that it will become even more possible and feasible as the evolution of MCP progresses, as more clients support advanced MCP features, or maybe as other protocols emerge. And so this brings me to the conclusion of this talk. To summarize the key lessons: number one, prefer MCP tools to CLI tools. Hey, this is MCP conference and not a CLI conference, clearly. We want to use MCP. Expect the unexpected. Do test your implementations across multiple LLMs and multiple MCP clients. That's important. And you will discover something that's unexpected. Meet users where they are. It's the same point. It's why we created this NeoBridge tool. You should not assume that your users will be using ChatGPT. They can be using anything, and you want to cater to them. Don't let the protocol limit you. There are ways to build sophisticated systems on top of the protocol as it exists today. And thank you for your attention. We have a table outside of this room. We want you to come and talk to us. We'll be happy to share more of our experiences building MCP or talking about Neo or anything else that Pulumi does. So please feel free to stop by. Thank you.